Okay, so back to the solution concept itself. It is focused on reduction of equipment failures that can lead to power outages. So the first thing I want to do is share a little bit of data with you around what drives power outages. And there's a term here, system average interruption duration index. It's quite a mouthful to say. We use SAIDI for short. This is a commonly used reliability indicator for electric power utilities. And essentially, it's the average duration for each customer that's served. Now, the pie chart here shows the typical values for US utilities, and our solution directly addresses this equipment failure category that you see, but also in a little more less direct way is impacting this unknown category. So essentially, we have the potential to impact up to half of the outage drivers. As our lives and, oops, sorry, that advanced before I intended it to. As our lives and livelihoods are increasingly dependent on power, both commercial and residential customers alike have this expectation of always on. Any outage is unacceptable. And as such, this solution is really targeted at driving substantial progress in pursuit of that perfection, that idea of perfection, that power that's supplied to us should be there without interruption. So now that you kind of understand why we're after this solution, I'm going to go into a little bit more detail about how it works. So we have a partner in Exactor that develops this sensing capability, and these sensors are mounted to a fleet vehicle. It could be any fleet vehicle. We're using garbage truck here just for sake of simplicity in explaining how a vehicle that runs regular routes within a particular geographic area can help us with this coverage. The sensor itself is activated by partial discharge, which essentially is a localized breakdown of the electrical insulator that's separating two conductors. So whenever this partial discharge is initiated, we see high frequency transient current pulses that appear and persist for nanoseconds to up to microsecond, and they disappear, then reappear repeatedly as the voltage sine wave crosses through the zero crossing. That's important because these high frequency transient currents, they also broadcast a small amount of energy in the radio frequency spectrum. And that's what Exactor has perfected. They've patented this capability to pick out that specific energy in the RF band and then separate it from all the other radio traffic that might be in the RF spectrum. So let's see how this might work in action. And a little slow to load there, sorry, probably the animation. So in the animation, you see a garbage truck with an Exactor sensor on it. It's traveling normal routes for weekly trash collection. The data is continually collected as the vehicle's in motion. And by the nature of the routes taken, a single sensor can typically cover the space occupied by approximately 25,000 households and businesses. So Exactor provides this data acquisition as a service to SAS. And the beauty of that is that neither SAS nor the utility end client need to own or install any additional hardware to activate this solution. So what about SAS? What are we doing? So SAS Analytics capability will be used to enable some key features in this solution. First, automated aggregation and grouping of the degradation signals. Next, intelligent location matchup of the degradation data to specific utility asset locations. Then we're doing proximity corrected signal strength for consistent trending and comparison. And finally, we're doing some prediction of ground truth findings based on degradation signal behavior. This combines trends as well as interactivity effects with temperature, humidity, and barometric pressure, which are also directly measured by the sensor in motion. Now, what we're providing as the primary output to the utility is a prioritized listing of the distribution equipment that requires proactive repair or replacement prior to causing any power interruption. This is where we tie back to that concept of SAIDI that I introduced earlier. That's the Interruption Duration Index. And because we can rank the degraded components in order of the SAIDI impact they will have if and when a failure occurs, then the utility can be much more proactive with scheduled maintenance. And because they can be proactive and more efficient with the scheduled maintenance, they can address more items during normal business hours. So we reduce the amount of time that crews are working at night or in inclement weather conditions, and thereby reducing injury rates as well. There are also several indirect benefits, and these include improved customer satisfaction, as well as reduction in financial penalties that can be levied by regulators in each market. That's a quick summary of this solution, and I'm going to turn it back over to Jason for the wrap-up.